In this video, we are going to look at inductive sensors. An inductor is an electronic component that stores electric energy as a magnetic field. And the three most important equations to understand the operation of an inductor are given on this slide. The first equation is this L equal to phi over I. What this tells us is that as some current is passed through an inductor, there is a magnetic flux generated in the inductor. And the magnetic flux is dependent on the inductance of the inductor, some constant in the inductor. Okay, the voltage across the inductor is given by how fast the current changes through the inductor. So V equal to L di over dt. And the energy that is stored in the inductor, mostly as a magnetic energy, is given by 1 upon 2 L into I square. So how does the inductor work? As current flows through an inductor, the inductor generates some magnetic field, and this magnetic field holds some energy in the inductor, and the rate of change of the current induces a voltage across the inductor. Now, another way to look at the inductor would be to say that the voltage which appears across the inductor is because of the change in magnetic flux in the inductor. And that can be derived just by combining these equations as follows. So we have V equal to d phi over dt, which is the same as L di over dt that we wrote before. What is an inductance depend on? The inductance L is dependent on the number of turns of the coil, and it is dependent on a quantity called the permeability of the medium. It is also dependent on a geometric form factor which takes into account the shape of the coil that we are using. So for example, this kind of an inductor which is shown in this image, the inductance is given by N square A over L. And there is this permeability. This is the permeability of vacuum, and this is the relative permeability of the medium that we are using. Now we can have several different kinds of inductive sensors. So I have just placed here some kinds of inductive displacement sensors. Now this particular sensor works because there are two inductors in series, and this wiper goes up and down, changing the number of turns in one of the inductors, and that measures the displacement. In this case, the medium starts to move and the permeability through the inductor changes, and therefore the inductance changes as there is a displacement. This is a rotary inductor, a rotational sensor, which works in almost the same principle as this linear sensor. This sensor works on the principle again of change in permeability. As this core moves closer to this inductor, the permeability of the medium across this changes, and therefore the inductance changes. In fact, this sensor is also a kind of a differential sensor because there are two inductors connected here, and depending on the movement of this, one of the inductors will have lower inductance while the other has higher, will have an increase in inductance while the other has a decrease.